Thank you for watching this video. Please click on the like and subscribe buttons so that I can continue to make more videos like this.
Now we're on sheet E 4.1 and it's the power plan. And again, the scale is 1/4 inch is equal to a foot. Just like with the lighting plan and the power plan, we get kind of a bird's eye view of this build out, and we can get an idea of how we might want to start running our conduit in a nice, efficient way, again using the structural members that we have already existing in the building. So let's get right into this. I want you to look right over here. We have key note 1, and it's the same here. This is panel E4, panel E5. So let's read our key notes. It says new 225 amp, 208 Y/120 volt, 3-phase, 4-wire panel board, total of 2. Refer to sheet E5.1 for panel schedules and one-line diagram. Now, this is where our panels are going to be located, and this is the first place that it shows up here in the prints. And it tells us that our panel schedules are on sheet E5.1. And we were there before when we had our lighting schedules. And the sheet that has the panel schedules on it is going to be one that you're going to be referring to quite a bit when you're doing your construction. So we're going to learn how to use that and learn how to navigate between the pages very well, like we've been doing. Now, of course, you should read all the general notes and even the keyed notes too. But let's look at one here. This is keyed note number 2. And if we look at it, it says new 3/4 inch conduit, 6 number 12 wires, okay, and a number 12 ground from panel, and circuit numbers as noted. Okay, and it says we're going to power to receptacles as shown. Alright, now there's a couple things I want to point out here. We're going to take a closer look at this right now. Okay, so here we are taking a closer look, and that's where we had our key note 2. We have E5, and that's the panel E5, and this is 2, 4, and 6. Those are circuits 2, 4, and 6. We have some symbols here. We know that's the receptacle. We know this triangle that's half black and half white, that's going to be a phone and a data. And we know that this receptacle is the same as this receptacle here. This number 2 right here, that's going to be circuit 2. And if you go in your print and go up to the next one, you'll see a 4, and that's circuit 4. And at the top you'll see a 6, and that's going to be circuit 6. Now remember, on page E0.1 we had some electrical symbols, and we mentioned that when you had a box around a symbol, it meant that it was going to be in the floor. And these are in the floor. And this is like a table that's going to be like a workstation for 4 people, and the power is going to be in the floor. Now, because the box is around both plugs and the phone and data outlet, that means that they're all together in the same box, and they make special boxes for this that have a little divider that keep the voltage from the electricity from getting into the signal for the computer and the phone. We have a key note 7, so let's look at that. And it says new floor box with devices configured as shown, typical of 6. So there's 2 here, and then up where circuit 4 is and circuit 6, you can't see on the screen, there's a total of 6 of those you can count. Each one shall have 2 3/4 inch conduits routed below the slab, and it'll have 1 for power and 1 for data and phone. Look here, we have this dotted line, and again, if we go back to E0.1, if we look at our symbols for conduit, when it's a dotted line like that, we know it's underground. Now what they did, instead of running a 3/4 inch pipe conduit, they ran what's called Walker duct. And it's kind of a square, a rectangle, and Walker duct is still a conduit. It's not, some people don't think of it that way, but it is a conduit, and there are actually 2 Walker ducts that were ran. One for the data and one for the power. Walker duct is very commonly used when you have to put something like plugs or data ports into a floor. Now I want to show you another case where we have some underground. So we're going to take a look up at the top left corner of the print where we have the reception area just above the bathrooms. So now we're in the top left corner of our page, and we have this area right here. We have two dotted lines, and again we know that those are underground conduits, and we have a key note 9. So let's look at that key note. Route conduits under the floor slab and stub up devices mounted on the millwork. So there's going to be, looks like some built-in kind of a desk here for a reception area, and so there's going to be a plug and a phone data jack there. Notice the conduit here. It has little, like a circle. On the conduit symbols on page E0.1, that's a stub up. So this had to be put in on the underground and had to stub up above the floor. And what you do with this, you stub this up to the ceiling, through the ceiling to a junction box so that this plug can get into it, and then it'll go down the wall, through the wall, under the floor, and stub up here. And of course there's another stub up here, but these symbols right here are kind of in place where those will be, and the fact that you know you've got a stub up here and it shows an underground, it's obvious a stub up has to come there. Okay, and another thing here at this plug, we have an 18. That means that circuit 18 is what powers that plug. So now let's go back to our plans, and we're going to take a closer look at some of the offices. We're looking at some of the offices right here, and we're on the right side of the print. Notice up here we have a outlet, and that's circuit 10. And we have a phone data. Now it looks like this line goes through this phone data to this plug here, circuit 12. Now that does not mean that you run the conduit from here and you run it through this device and then out of this device to here. That just simply means the power goes from here to here. And when you put it in the walls or go overhead in the ceiling, you're going to have to go around it. But you need to have this, this data port next to this power for this workstation. Now you say, well, why did the architect draw it that way? Well, it's a computer program, and if you want to re-engineer the software, it's very expensive. And again, this is something where you're just going to have to catch it, and it's fairly obvious. You're not going to tie the voltage here from the plug and run it through the same box here. You're just not going to do that. Okay, now we've talked a little bit about some of these datas. Keyed note 8. And we actually see that just below here, just off the screen, there's key note 8, but it's pointing to a phone data, and it applies to each of those. So let's read it. Key note 8, new phone data outlet mounted at 18 inches above finished floor. Contractor shall provide and install new 3/4 inch conduit with a pull string from back of box to 6 inches above the ceiling for phone data wiring by others. 18 inches above the finished floor. Is that going to be to the bottom or to the center of the box? Well, what did our notes on E0.1 say? We want to put that to the center of the box. We also have to have this 6 inches above the ceiling. Well, how high is the ceiling? Where are you going to look to find that? I want you to pause the video right now and find out how high those ceilings are. These finished ceilings are 10 feet high, and you can find that on the finished schedule on sheet A 2.6. You can also find that on sheet A 6.1, the reflected ceiling plan. When you're making your stub-ups, you know that the conduit where you stub that out has to be at least 10 feet 6 inches above the finished floor. Now that stub up has to be 6 inches above the finished ceiling height, and again that's so the person can get the tiles out if they have to get to it. But then you don't want to make it so high that it's too hard to reach off of a ladder. So you can be a little bit higher than 6 inches, but don't make it too hard to reach that to work on. Let's move from here over to the break room. and let's look at some things there. So we're here at the break room, and let's take a look at something here. Right at the very top we have a key note 5, and real quickly that's telling us that that's going to be the power for the range. And the symbol here, if you remember from page E0.1, it's a circle with that triangle in it, and that was for the single phase plug 240 volt. Now we also have another plug. We also have here, it's the panel E5, circuits 40 and 42. Okay, now down here we have a home run, and this arrow, when it comes off of some circuit numbers, or comes off of a plug or a piece of equipment, and it's got the numbers here, that's telling you that's the home run conduit there. I should have pointed that out sooner. Okay, it goes to panel E5, and it's circuits 24, 26, 28, and 30. We have a circuit 16 here, and a 16, and it goes to circuit 14 as well, and it continues down, and it has its own separate home run. So we have circuits coming from 3 different home runs, and let's count them. We got 1, 2, 3, 4, 5, 6 plugs and 1 switch that we have to account for in this break room. Remember, in the break room we have some appliances and some a countertop in here as well. So when we look at our plugs, we have to make sure that we install them in the proper place, and we've already looked at this location before, and we're going to come back to it. Now remember that our plugs, we're going to be at 16 inches to the bottom, unless otherwise noted, and our switches, we're going to be 46 inches to the bottom, unless otherwise noted. Let's look here. Now we have a switch, and you can see there's a little line to this 26. So the switch is going to control this plug that is circuit 26. Now there's a circuit 16 here, and you don't want to get these confused. So little things like this, you have to find that out. But I'm going to show you another way as well where you can double check that. Let's find the layout of all of these plugs, and let's make sure that we get them in the right place for the right usage that we want. Remember when we looked at this earlier, we were on the A sheets. It was sheet 4.1 where we looked at some millwork. I want to go to that right now, and we're going to review what we looked at then, because we have a little problem we have to solve here. We have 6 plugs and 1 switch. Okay, and on that millwork diagram it showed places for only 4 electrical outlets. So actually, before we turn there together, I want you to look at that yourself and see if you can figure out where everything's supposed to go. Just pause the video and spend a few minutes on that your own, and I'll meet you there on the A sheets. So we're at sheet A 4.1, millwork elevations, and we're kind of at the bottom left part of the sheet. So we looked at this before. Remember, we had 6 plugs and a switch to account for. Now if we look, this E means it's an electrical outlet, so we've got 1, 2, 3, 4. There's only 4 on this diagram, but we have 6 plugs and a switch we have to account for. Let's work this out and come up with our solution. This key note 12 points down here, and the notes for these are just off your screen here. But if you go to 12, it says electrical outlet. See electrical drawings. If we look at note 11, okay, it says oven or range. And remember, that was our circuit 40 and 42. So that's one of those plugs. Let's go to our note 10, which points here, and it says it's a dishwasher. And we have a plug here, so one of those circuits is going to be for that dishwasher. But which one? We'll find that out. Let's go over here. This is note 9. It's a refrigerator. So we know the refrigerator is going to get its own circuit. And this other plug is a plug that's above the countertop. This right here, if we look at it, note 8 says that this is a sink. Okay, now this information is going to be useful for us. we need to figure out what are we going to do. We accounted for 4 of the plugs, but we need to get more specific information. Well, there is a place on the print where you can find out specifically what each circuit is used for, and that is the panel schedule. And the panel schedule is sheet E 5.1. So we're going to go to sheet E 5.1 right now and see what we can determine. So we're at sheet E 5.1. At the bottom of the page in the middle is the panel schedule for panel E5. Now, the circuits we need are concentrated in this area, so we're going to take a close-up look at that area right now. This column right here is going to be our circuit numbers, and we're going to get into how to read panel schedules in detail a little bit later. Remember, we had our circuits 40 and 42 right here. Those are for the range, the oven. So we pretty much figured that one out on our last diagram. Now the other circuits we had were 24, 26, 28, and 30, and also 16. Let's look here. 24 says that it's a refrigerator. So we know where to put circuit 24. Circuit 26 says it's a garbage disposal. We know that that's going to be a piece of equipment and it's going to go underneath the sink. That's why I pointed out the sink back on drawing A4.1. So we know that we have to go into that cabinet and we put the plug in there so that you can plug in that garbage disposal. You'll just have to work off the millwork drawings and lay that plug out so that you're not in a dividing wall and so that you can have accessibility to the other plumbing equipment that's in that sink. So that is one of the missing plugs because there wasn't one of those little rectangles with an E next to it under the sink. Go back to A4.1 and take a look because they did not have one in that sink area. Circuit 28 is the dishwasher, and we accounted for that one as well. Now circuit 30 is the microwave. Okay, now the microwave, in that situation you can either cut a hole in the cabinet and drop your cord through the countertop and have the plug in the inside the cabinet, or it's just going to be an above countertop plug. That is where you should put it, above the countertop. Now, it didn't have a specific note on our power plan to say, hey, put this above the countertop. So here's how we're finding out where to put it in there. And we were given a height for that on what it should be, 46 inches to the bottom above the finished floor. And the reason it didn't show up necessarily on the architectural prints, I'm not really certain on that because it did show one plug. However, it doesn't really matter because it's an electrical appliance and the electrical circuit was shown to put in, and it was on the power sheets. So we're going to coordinate that with the general contractor, find the best place to put it, probably at the end of that counter close to where the stove starts there. You'll be able to find a place to put that. Let's go back to circuit 26. We had a garbage disposal. Okay, now that's what the switch was for. Okay, so we're circuit 26, so the switch would go for that. Now we had another plug here. It was circuit 16, and it's a recep for a break room. That was the one that was shown above the countertop on sheet A4.1. Now what we're going to do, since all of these are in the same panel, we're going to put a 2-gang box and put our switch and that plug in that same box. We're not going to put 2 outlet boxes in that same area. That just kind of looks too clunky and cluttery. We just put them together, but we just have to make sure we put the right circuit to the disposer when we do that. Let's go back to our power plan. Okay, so we're back to sheet E 4.1, back at the break room. So when I asked you to pause the video to see if you could figure this out, was your answer close to what we came up with? So again, we're going to look at it. This is going to be for the refrigerator, circuit 24. 26 will be for the disposer, garbage disposal, and the switch controls that. It's going to be in a 2-gang box with circuit 16, which will be a GFI plug above the sink. 28 will be the dishwasher. 30 will be for the microwave, and again, that's going to be above the counter that goes over the dishwasher. And this circuit 40 and 42 are going to be for the range. Now I want to go to note 4, and it says all receptacles within 6 feet of the sink shall be GFCI type. And we mentioned that already about this plug here. It had to be GFCI type. And since this one, if it's within 6 feet of the sink, it also has to be GFCI type. And that is part of the electrical code as well. While we're here at the break room, I want to point out something. Remember this wall here was going to be a partial height wall, glass block wall. Okay, we had another one of those over by one of the offices, and it's going to create a situation with our electrical installation. So let's take a closer look at that right now. So here we are in the office area, again, office 104 and 103, and we have like a partial height wall here. And if you remember from looking on sheet A 2.2 of the floor plan, right in here we had a diamond with an F in it. So let's just pause for a moment and take a look at that right now. And also while you're at it, at the break room, we're kind of off the screen, but at the corner wall of the break room there was a diamond with a D and a diamond with an E in there. So take a quick look at that on sheet A 2.2 of the floor plan. So now we're back here, and we know that that diamond means that we have a window that has to go in there. We have a window schedule on A 2.5, and we'll tell you the type of window to use on there. And it's going to be kind of like a glass decoration. You can think of it as a glass block wall or whatever they're putting in there. The thing I want to point out with right in here is they're showing this conduit, and it looks like, hey, it's going to go right through here, okay? Right through that glass. Let me explain that in a different way. If you're running the conduit and it's already framed up, you just can't take it around here and through the wall, okay? Because there's going to be a glass wall here. You can't have the conduit through it. So the conduit has to go up and over, and then it has to go back down to make it into this plug right there to continue it. Now again, you could say, well, why aren't they showing that? And the answer is, they are showing that. When the architect puts this in here and tells you to run the conduit, he doesn't tell you the height to run that conduit unless it specifically affects that device. So in other words, you're going to have to use your brain power and determine, can I just run this in the wall, or do I have to go up and over? Do I have to even put in another junction box or something? What's the best route for me to take? You are going to be expected to catch this. And it's not a mistake by the architect. Some people blame the architect right away. That's not a mistake by the architect. It's your job to run this in the best way. Maybe it takes this path, but you just have to go up above the wall, above the ceiling, and then you go over and down. And then from back here you can go back through the walls again. But again, you are going to be expected to catch that, things like that in your construction. Now on the break room, that was not an issue because there's no conduit that has to be run in that area. That's why you have to reference that. Again, we use A2.2, the floor plan, and we found out that we had those windows. And then we checked our window schedule on A2.5. I want to go take a look at the janitor closet, and that's going to be at the bottom left page of your sheet right now. Here we are looking at the janitor closet, and we're at the lower left corner of the sheet. We can see that our panels are right here, E4 and E5. Let me point out something first. This circuit, okay, 14 here, and we have the arrow up. panel E5, circuits 14, 16, 18. Now even though we're this close to panel E5, it's not connecting it in. In other words, it's just saying you need a home run here, and it's going to leave it up to you to find the best route for that home run with your building structure. Now you see a line coming through here past the panel. Well, off the screen up here there's another plug, circuit 14. You can see it at home on your print. It's real easy to see. It's just saying those plugs need to be tied together. But when it comes to selecting the home run, it's going to be up to you to find the best route to this home run. Typically the home runs come through the bottom or the top. This plug, I'm going to say, it comes out the wall into a ceiling member and comes across. And there's other plugs in this home run. Remember, circuit 16 was up in the break room, so it'll probably meet at a junction box, and then from there come to the top of this panel. Let's go and look at our janitor closet. We have a note 6 here, a keyed note, and it says new 3/4 inch conduit, 3 number 10 wires from panel, and circuit number is noted, for power to the hot water heater. So we know that this is a hot water heater, and the circuits panel E5 are 13, 15, and 17. Okay, now this symbol right here is a disconnect, and that's on our drawing. Our symbol's given on E0.1. You can find that in the electrical symbols. So that's going to be a disconnect switch. We have this right here, and it's got an M on it, which typically that's going to be a motor, and it's got a home run, but we can't see what that is. So how are we going to find out what that is? A way that we might find the answer to this is to go to the panel schedule. And we've already looked at that a little bit earlier, but let's take a look. It looks like there's a 4, and it looks kind of like it's a 3. So let's go to the panel schedule and check for circuit 34. And let's guess that it's going to be for E5, because since that's what's for the hot water heater, let's see if they didn't put this recirculation pump out of the same panel. That only makes sense. And we're going to check circuit 34 and see if that's what that is. Now we're looking at the panel schedule for E5, and it's on sheet E5.1. We were there earlier, and let's look at circuit 34, and it says water heater recirc pump. We guessed right, but we were also given quite a few clues to help us guess right. One thing you can use the panel schedule for to help you find something like that. We're back to our power plan, E4.1, and I want to point out something to you. On our notes here, note 7, and you should have read all the notes, but let me mention, it says contractor shall provide and install receptacles for all equipment to match vendor furnished plugs. Now on something like this, you would find if there was a lot of equipment, like a lot of times in an area that had a kitchen with a lot of different equipment, and it had multi-phase plugs or plugs greater than 20 amps, sometimes some 30 amp plugs or whatever. Those would be the kind of things where you would have to do some coordination there. This is a relatively simple build out, and your plugs are going to be your duplex plugs of 20 amps. Now we had a range plug up here in the kitchen, so you can look for things like that, but basically this is a pretty simple build out, but I just wanted to explain that note because there could be some questions on that. So that's generally an overview of the power plan. Like the lighting, you want to find the best routes you can for your home runs. You also use it, of course, for your plug locations. A comment I want to make here, we've been going through some things and you might think, well, I already knew that. Well, I'm glad to hear it. That means you're learning from this lesson. What really makes me glad to hear comments like that is we're getting into the things that are even a little bit harder as we go along. But you're understanding them more because you're building up a base of knowledge. Even without knowing it, you've learned quite a lot about blueprint reading already. We're most of the way through this lesson. The lighting and the power plan pages are going to be the two pages that you're going to be using the most. And of course, again, we mentioned from these pages you'll be flipping back back and forth to some of the other pages the most from these pages. But at this point in time, a lot of things should be soaking in. The rest of this lesson is going to be things that I think are going to make quite a bit of sense to you because we have such a good foundation. Now that we've said that, let's go to the next sheet, which is E 4.2. The next page of this lesson is sheet E 4.2, Mechanical Power Plan. Now the scale on this sheet is 1/8 of an inch equals 1 foot. And of course we should read the key notes and the notes every time. Let's look right here. We have key note 5 and it says existing 1200 amp, 280, 120 volt, 3-phase, 4-wire SES. In other words, this is where the electrical feed from the utility company comes in. And remember, our panels were over here, and there will be a disconnect to shut down panel E4 and E5 over here. So this is where the main panel for the whole building is, and this is the first look we get at that with these prints. This page on the prints is a rooftop look of the prints, and it's the mechanical power plan. The heat pumps, the air conditioning units are on the roof, and we can read our key notes. It goes into detail on these. Now I don't want to read them, it's a lot of numbers, but to get into it, it tells you the conduit. It uses number 8 wires and a 10 ground from panel as noted. It tells you the type of fuses and to use a fuse disconnect for these. So we're going to zoom into this part of the print now. This is our section, our build out part of the building, and we have 4 heat pumps if you remember. Here they are. And you remember the types, they had A, B, and a C type, and here's an A and a B, another A, and here's the C. We have here panel E4, circuits 2, 4, 6, E4, 8, 10, 12, and these next two are on panel E5, 1, 3, 5, and E5, 7, 9, 11. So they've split the heat pumps up onto 2 different panels, so you just have to be aware of that and just don't make an assumption that they all go to the same panel. Okay, another thing we look to at the heat pumps, you can see, of course, we got the line with the arrow which shows home run. We've covered that symbol before. But there's a little box on the side of each of these where the arrow comes out of. That's where your disconnect goes. On your heat pump, it may not actually be on that side of the heat pump. It just depends on the model. And this is just, again, a symbol that the architect puts on there. So you actually have to look at the heat pump, how it orients on the roof, and put it on appropriately. You can find that information. Remember sheet M 2.1. We've already looked at the packaged heat pump unit schedule. You can get the model number and all of that, and you can actually find the orientation on the unit and find out where that disconnect should go on that unit. And that way you can properly plan your stub outs. Now the nice thing about these units here is that there's a little cabinet in there, and the stub out actually goes into the unit. You don't have to put a stub out beside the roof and make another roof penetration. So that's what made these units pretty nice. Another thing we see here, we got this line E4 circuit 14, and we have a note 4, and it says 3/4 inch conduit, 2 number 12 wires, number 12 ground, be used for each 20 amp circuit. These are the convenience receptacles for your roof. Within a certain distance of each of these heat pumps or any piece of equipment on a roof, you have to have a receptacle so that if you have to do maintenance work on that piece of equipment, you have electricity there. So here you have one over here, and this one will be shared by these 3 because it's close enough. Now let's take a look here. It says WP. From our abbreviations, we know that that means weatherproof. and GFCI is a ground fault current interrupter. And so it's a GFCI plug, and it's a weatherproof outlet. So that's what that takes to make that work. Let's refer to note 6 right now. It says, all exterior receptacles shall be furnished with a Tay-Mac cover. So we have these two receptacles here. You might be tempted, if you don't read this note, to just put the standard Bell is a common name for a company that makes weatherproof boxes. And you might just be tempted to put a regular Bell cover over it. A Tay-Mac cover is different. And this is what this is calling for. So you have to read these details and make sure you install the right features. Otherwise, you're going to have to go back and change that out. We did mention about sheet M 2.1, and we already looked at that earlier, the packaged heat pump unit schedule. But I would like you to turn to that page and review the equipment here, these 3 heat pumps. Just go over the features of those heat pumps again. Please do that before we go to the next page of our prints, which would be sheet E 5.1.
Thank you for watching this video. Please click on the like and subscribe buttons so that I can continue to make more videos like this. If you find this video helpful, please consider donating using the PayPal link below. Thank you.